Welcome to the Deep Dive. Today, we're diving straight into the rules of the road for lifting equipment safety set by LEEA, the Lifting Equipment Engineers Association.
Exactly. And we're specifically digging into your source material, this LEA 042 Technical Requirements document. It's, like the operating manual for LEA members.
Right.
And it pulls heavily from UK safety laws, things like LEEA and PUWER.
And this isn't just like good advice, is it?
Yeah.
It's mandatory for members.
Absolutely. Mandatory for membership. And it really does set a benchmark for best practice internationally, too.
So our mission today is to cut through maybe the jargon and pull out the really crucial bits. What's actually happening behind the curtain to keep lifting gear safe?
Well, it covers a huge range from, how a company is set up, the people involved, right down to the nitty-gritty of testing and the paperwork trail.
Okay, let's unpack this document then and see what we find.
Right. So at its heart, this document connects directly back to UK law. The Health and Safety at Work Act is the big one. But then a low-layer lifting operations and lifting equipment regulations and PUWER provision and use of work equipment regulations, those are the key pillars it builds on.
And lifting equipment isn't just cranes and hoists, right?
It can be wider. It could even include, say, fall protection harnesses if they're used to lift someone in a rescue scenario.
That makes sense. Law provides the base. LEEA adds the detail. So who are the key people doing the critical examination work? The document talks a lot about competence.
It does. And competent person has a specific legal meaning. It's someone with the right practical and theoretical knowledge for the specific equipment they're looking at.
So experience, too.
Yes, experience is crucial.
Yeah.
They need to be able to spot defects, understand why they matter, and judge the risk.
So it's not just about having a piece of paper or a certificate.
No, not just that. It's about proven ability. The document lists ways competence can be shown, things like holding relevant LEA diplomas for different product types, or having documented training under supervision, maybe national qualifications for design checks, or importantly, qualifications for NDT non-destructive testing.
NDT that's looking for hidden flaws, isn't it?
Yeah.
Without damaging the item.
Exactly. Things like cracks below the surface. So qualifications like AS&T or PCN Level 2 are mentioned. It's about checking what you can't necessarily see.
Right. So that requires specialist skills.
Definitely. And companies need enough qualified people, and they have to check any subcontractors they use are competent too. It's all about ensuring the right skills are applied.
Okay, but you mentioned something else, a non-negotiable for these examiners.
Yes, this is absolutely fundamental. Independence.
Independence.
The competent person examining the equipment must have, and I'm quoting the spirit here from the LEEA guidance, genuine authority and independence to ensure examinations are properly carried out and recommendations are made without fear or favor.
Without fear or favor. That's a strong phrase. Why is that specific point so vital?
Well, think about it. Their job is to find problems. Sometimes those problems might be expensive or inconvenient to fix.
Right.
If their independence is compromised, maybe they worry about losing work or upsetting the client, they might be pressured, even subconsciously, to overlook things.
So the integrity of the whole safety check relies on them being genuinely impartial.
Precisely. It protects the examiner's professional judgment and ultimately everyone who might be affected if that equipment fails. It's a cornerstone.
Makes total sense.
And beyond that individual competence and independence, the document also covers the company structure needed. Things like clear reporting lines, access to technical backup for tricky issues, having the right reference material, standards, laws, that sort of thing.
And insurance, presumably?
Yes. Adequate liability insurance is covered too. Professional indemnity for the examination work, and product liability if the company also manufactures equipment.
Okay, let's shift gears to the paper trail. Section 2. This seems like a really big deal in the document. Records, documentation.
Oh, absolutely. It's the backbone of accountability, really. A key document is the report of thorough examination.
Right.
And the critical thing here is that it must be made contemporaneously. At the time of the examination, or very shortly after, not weeks later from memory.
Okay, immediate recording.
Yes. And while the format isn't rigidly prescribed, it has to include all the specific information laid out in LEEA Schedule 1. You can't just leave bits out.
No cherry picking the easy part.
Exactly.
Okay, that's for equipment that's been examined. What about brand new stuff, straight from the factory?
For new equipment falling under the machinery directive, you need an EC declaration of conformity.
To don't EC.
Yes. That's the manufacturer basically stating, formally, that the product meets the essential safety requirements. The document clarifies who issues this, the maker, their authorized rep in the EU, or whoever first places it on the EU market.
Got it. Now, you highlighted something in this section earlier that sounded serious, almost a warning.
Yes, this is really important. Section 2.3.1, it makes it crystal clear. It is illegal to copy information from someone else's certificate, say a manufacturer's test certificate, onto your own documentation and imply you did the work.
Hang on. So I buy a shackle. It comes with the maker's certificate. I can't just type that info onto my company's headed paper and issue it as my report.
No, that's exactly what you can't do. It's sometimes called back-to-back certification. It's considered fraudulent because you're misrepresenting who performed the verification or test.
Wow.
People have actually been prosecuted for this. It undermines the entire chain of trust and traceability. Your documents must reflect your work.
That's a huge point. The paperwork has to be genuine, reflecting actual actions taken by the person signing it.
Absolutely. The document also mentions the job or technical file. This is essentially the equipment's history file.
What goes in there?
It needs details for traceability materials used, components, processes. For manufactured items, this file, including that original EC declaration, needs keeping for at least 10 years after the last item of that type was supplied.
10 years. That's long-term accountability.
It is. For other examination records, the minimum is usually 2 years. But critically, the original examiner's report, the one made contemporaneously, must be kept alongside any formal typed-up version.
Okay, retaining the source document. What about when things go wrong? Reporting defects.
There needs to be a system. First, promptly telling the equipment user about any defects found, and recording that you told them.
Right.
But then there's a crucial legal bit under LEEA. If the competent person finds a defect that poses an immediate or imminent risk of serious personal injury.
Okay, a really dangerous situation.
Yes, they have a legal duty to report it immediately to the employer using the equipment and report it as soon as practicable to the relevant enforcing authority, like the HSC in the UK.
So straight to the user and potentially straight to the regulator if it's really bad.
Exactly. And the member company has to record that those reports were made too. It closes the loop.
Clear safety trigger.
It is. And just finally, on paperwork, the document mentions providing instructions for safe use and maintenance and having a system to update users if instructions change. That links back to basic duties under the Health and Safety at Work Act.
Okay, that covers exams and new gear. But what if a LEEA member company is selling equipment they didn't make? They buy it in from someone else, factored goods, the document calls them.
Yes, Section 3 deals with this. If you're supplying factored goods, you still have responsibilities. You need to ensure the equipment complies with the relevant EU directives and also Section 6 of the Health and Safety at Work Act, basically, that it's safe to supply.
How do you do that if you didn't make it?
Well, a key part is getting the necessary documents from your supplier.
Oh.
You need to obtain that EC declaration of conformity and the instructions for use from whoever you bought it from. So you can pass them on to your customer. Your customer needs that documentation to meet their legal duties under PUWER, for example. You're a vital link in that chain.
Right, so you're responsible for ensuring that information flows down the supply chain.
Exactly. If your supplier doesn't provide it, you have an issue passing it on.
What about putting your own company brand on these factored goods? You know, white labeling. That happens a lot.
It does, but Section 3.2 has a very important point on this. If you put your brand name or mark on factored goods, you legally take on the full responsibilities of the manufacturer.
Whoa, hang on. Just putting my logo on it makes me legally the manufacturer.
According to this LEEA requirement, yes. It means you are taking full legal responsibility as if you designed and built it yourself.
That's significant. So it's not just marketing.
Not at all. It implies you must be able to compile, or at least have access to, the full technical file for that product. And you'd need to be able to issue the EC Declaration of Conformity in your own name.
So you're basically saying, I stand behind this product entirely.
Precisely. It's a complete transfer of liability onto the company whose brand is on the product. That's a critical takeaway for anyone involved in own branding.
Okay, moving into how things actually get checked. Verification, testing. Section 4 and 5 seem linked here.
They are. Section 4 clarifies that thorough examination isn't just a visual inspection. It includes any testing the competent person thinks is necessary to be sure about the equipment's safety.
So it could involve more than just looking.
Oh, definitely. It could involve functional tests, electrical tests, NDT like we mentioned, or proof load testing applying a specific load, whatever the competent person needs to do.
Right. And the gear used for those tests, the testing machines and load cells in Section 5, they need to be accurate, I assume.
Accuracy and calibration are paramount here for things like tension or compression testing machines or load measuring devices.
The things that measure the force.
Exactly. They must be calibrated regularly, typically every 12 months, following a standard like BSEN ISO 7500-1.
Okay.
And here's a key detail. The required accuracy for the applied load. It generally needs to be within plus or minus 2% of the target load.
Plus or minus 2%. That's quite tight.
It is, because you're verifying something critical. If your test machine isn't accurate, the test result is meaningless, potentially dangerous.
Yeah, makes sense.
The guidance even touches on nuances like reading dials versus digital displays, resolution, human error. It also mentions a slightly wider tolerance, minus 0 plus 10%, derived from an older standard.
Minus 0 plus 10.
Yeah, BS 3243. But the guidance suggests this is more for manufacturers testing their own new products. If you're testing someone else's equipment and service, you really want confidence in that lower limit too, so the plus minus 2% is more generally applicable for verification.
Okay. Different tolerances for different situations, perhaps. What about safety during the testing?
Absolutely covered. Section 5 guidance stresses that test areas must be big enough and properly designed or guarded to protect people if the item being tested fails catastrophically. You don't want bits flying off and hurting someone.
Practical safety. Good.
Yeah.
What else needs calibrating?
Electrical test equipment annually or per manufacturer guidance. NDT equipment, again, follow the maker's recommended intervals, even basic dimensional measuring tools.
Like rulers or calipers?
Yeah. They need periodic checks against a known standard. The required accuracy depends on the job, but it mentions plus minus 5% for measuring deflection on things like runway beams.
5% for deflection seems reasonable. Okay, practical question. What if a testing machine is broken or its calibration has run out?
Section 5.2 is clear on this. Any equipment that's out of action, broken, out of calibration, awaiting repair, must be clearly identified and isolated or quarantined.
So no one uses it by mistake.
Exactly. They suggest things like removing fuses, locking off power switches, putting clear do not use signs on it. Simple but crucial process control.
Prevents bad tests.
Okay.
And test weights, the actual lumps of metal or concrete you use.
Good question. If you're using test weights without a calibrated load cell in the setup.
So you're just relying on the weight itself being correct.
Yes. In that case, the weights themselves need to be verified periodically. Again, the target is usually plus minus 2% of their marked weight.
And how often?
Typically, steel weights every 5 years, concrete weights every 12 months, because concrete can chip or absorb moisture, changing its weight more easily.
Right.
And the device used to check the weights must itself be calibrated and traceable to national standards.
Traceability again.
Always. Although the guidance notes a good practice. If you use the weights with a calibrated load cell or weighing device in the system,
then you're measuring the actual force applied anyway.
Exactly. So in that case, the specific verification of the weights themselves becomes less critical because you're getting a precise reading of the load applied from the calibrated instrument.
Okay, that makes sense. Calibrate the measurement one way or another.
That's the principle. And finally, Section 5.7 just reminds us that the examiner needs the right facilities and tools for the visual examination part 2. Good lighting, maybe a torch, cleaning stuff, measuring tools, magnifying glass, even mirrors for awkward spots, and a clean area to work in.
All right, let's unpack Section 6 now. Material control and marking. Sounds like it's all about knowing what you've got and where it came from.
That's exactly it. Traceability. The document demands comprehensive control systems right from when things arrive.
What sort of things?
Raw materials, bought-in components, factored goods like we discussed, even equipment belonging to a customer that's come in for a repair or testing.
Okay, so everything coming through the door.
Pretty much. The key is maintaining identity and traceability throughout whatever process happens next. Manufacturing, assembly, testing, storage.
How do they actually do that? What does the process look like?
Well, checking goods against purchase orders on arrival, clearly identifying everything perhaps with labels or tags, storing things properly so they don't get damaged or mixed up.
Mixed up.
Yeah, imagine 2 types of steel bolts that look identical but have different strengths. You absolutely cannot mix those up, so segregation is vital. And isolating anything that doesn't conform wrong item delivered, damaged goods, materials without the right paperwork. Traceability is essential if safety depends on specific material properties confirmed by a supplier, or, heaven forbid, if there's ever a need for a product recall.
You need to know exactly which batches were affected and where they went.
Precisely. Traceable from source right through to the end user, ideally.
What about the finished product then, the lifting gear itself?
Every single item of lifting equipment must be marked with a unique identification number.
Unique, like a serial number.
Exactly. And this number isn't just for inventory. It's the crucial link back to its birth certificate, the original EC declaration or manufacturer certificate, and then to every subsequent report of thorough examination throughout its life.
So that single number on the shackle or the sling tells its entire life story if you have the records.
That's the idea. It's fundamental for tracking its condition through in-service checks and, again, essential if there's ever a safety issue or recall.
Got it. Are there other required markings?
Yes. Things like the safe working load, SWL, or working load limit, WLL, must obviously be marked clearly.
And how do they actually put these marks on? Stamping seems common, but could that damage some items?
Good point. Section 6.3 covers marking methods, stamping, stenciling, durable labels, tags. The absolute rule is the marking method must not damage the item's strength or function.
Right.
And the mark has to be clear, readable, and unambiguous throughout the item's accepted life. There's even a specific detail about hard stamping.
Oh, yeah.
For smaller diameter materials, like maybe chain links or rope fittings, if they're 12.5 millimeters diameter or less, the guidance suggests using stamps no bigger than 3 millimeters.
3 mil stamps. That's tiny. Why so specific?
It's precisely to minimize the risk of the stamping process itself, creating a stress point or a notch that could weaken the item. It shows the level of detail considered to avoid compromising the integrity of the equipment just by marking it.
That's a fascinating detail. It really highlights the engineering focus.
Okay, nearly there. Let's look quickly at Section 7, which deals specifically with hiring out lifting equipment.
Renting it out. That must bring its own set of challenges and responsibilities.
It certainly does. The core requirement for a LEA member hiring out gear is that they must inspect it between each hire.
Every single time it comes back.
Yes. This isn't the full, thorough examination, but it's a pre-hire check to make sure it hasn't been obviously damaged or isn't malfunctioning after the last rental.
Makes sense.
They also, of course, need a system to manage the legally required thorough examinations for their entire hire fleet, making sure everything gets its periodic checkup on time.
How does that work when equipment might be out on a job site for months?
The document mentions needing systems to handle that, either swapping the equipment out for an examined item before the certificate expires or arranging for the examination to happen on the hirer's site.
Okay.
The absolute bottom line is that they must have procedures to ensure only equipment holding a current, valid report of thorough examination is actually hired out.
So a LEA hire company can't just hand over a piece of kit and say to the customer, okay, it's due an exam next month. That's your problem.
Well, legally, the duty is on the user-employer, the hirer, to ensure equipment they use is safe and examined. However, LEA's guidance here sets a higher bar for its members.
How so?
It explicitly states that LEA's view is that the member company hiring out the equipment must take responsibility and have effective systems in place to manage the examination status of their fleet. They can't just wash their hands of it.
Okay. So it's about proactive management from the hire company, not just relying on the user's legal duty.
Exactly. It's a higher standard expected of LEA members.
That seems like a really important point for anyone hiring lifting gear.
It is. And one more thing from Section 7.2 evidence. OLALA Regulation 9 requires that when lifting equipment leaves one company's premises and goes to another.
Like going out on hire.
Yes. It must be accompanied by physical evidence that the last required thorough examination was carried out.
Physical evidence, like what? A tag. A copy of the report.
Could be various forms, but it needs to be tangible proof, traveling with the equipment, stating it's safe to use, and traceable back to the full report. Just having the report back in the hire company office isn't enough when the gear moves site.
Okay. Proof travels with the kit. And they also need to provide safety instructions.
Yes. The duty under the Health and Safety at Work Act to provide necessary information for safe use still applies when hiring out equipment.
Wow. Okay, stepping back and looking at everything we've unpacked from that LEA document, it's incredibly detailed, isn't it?
It really is.
From the absolute necessity of competence and, crucially, independence for the examiners, through the really strict rules on documentation, knowing what's illegal, like that back-to-back certification, the precision required in calibrating every single test tool, even down to the size of stamps used for marking, the need to track every material, and then specific rules for hiring gear out.
It paints a picture of, a comprehensive safety system. It's not just bureaucracy. Each requirement is there to build in a layer of safety competence, accountability, accuracy, traceability at every step.
So for you, our listener, what does all this mean? I guess it shows that behind every safe lifting operation, there's hopefully this whole network of rules, checks, and skilled people following rigorous standards like these LEEA ones.
Exactly. It's this system working in the background. And maybe a final thought to leave you with, building on that.
Go on.
We've seen the intense focus on things like calibrating test weights to within 2% and the serious view taken on fraudulent certificates. Now consider that level of rigor. How much hidden complexity and maybe how much hidden risk might exist in corners of the industry or in other sectors perhaps, where these kinds of detailed, auditable standards aren't being so strictly applied.
That's a sobering thought.
Yeah.
It really underlines the value of associations like LEA pushing for these high standards and maybe the importance of checking if your suppliers actually adhere to them.
It certainly makes you think about the hidden details that contribute to safety.
Indeed. A powerful point to ponder. Thanks for joining us for this deep dive into the LEA technical requirements.